Last in this series is we're going to find the derivatives of the other four basic trigonometric functions. We know the derivative of the sine function is cosine. We know the derivative of the cosine function is negative sine. At this point, we want to introduce the tangent, the cotangent, the secant, and the cosecant derivatives. So I put in a blank slide because I'd like to show how we develop those derivatives. Say we're interested right now in the derivative of the tangent function, one that we're going to find analytically rather than through a conjecture of its graph. So the tangent function we know can be rewritten as the sine over the cosine. So I'm going to rewrite this as the sine of x over the cosine of x. And I'm going to attempt to find this derivative with the quotient rule. So we would go low d high, right? So we'd go cosine of x times the derivative of the high function, which would be cosine x, minus high d low. So that would be the sine of x times d low. Derivative of cosine of x would be negative sine of x, and this is all over the denominator, or the low function, cosine of x quantity squared. So now we'll distribute. We have cosine x times cosine x, that's cosine squared of x, minus sine of x times negative sine of x, that's plus sine squared of x. And this is all over cosine squared of x. Well, cosine squared x plus sine squared of x is a Pythagorean identity. It's 1. And that leaves still a cosine squared x in the denominator. And because we know our reciprocal identities, and 1 over the cosine of x is the secant of x, we have secant squared x as the derivative of the tangent function. So derivative of tangent is secant squared. Let's say now I'm interested in the derivative of the secant function, SEC of x, secant of x. Well, we know from reciprocals, just as we used a while ago, that the derivative of secant could be written as derivative of 1 over the cosine function. And I'm going to attempt to find this derivative using the quotient rule. So with 1 being the high function and cosine x being the low function, we're going to start with low d high. So that would be cosine of x times derivative of 1, which is 0, minus high d low. So that'd be 1 over, or 1 times d low. So derivative of cosine would be negative sine of x. And this would all be over the low squared, so cosine of x quantity squared. Well, 0 times cosine of x is just 0. And negative 1 times sine of x is a positive sine of x. And then I'm going to, rather than write cosine of x quantity squared as cosine squared, I'm going to expand it and write it as cosine x times cosine x. And the reason I'm going to do that is because I can look at sine of x in the numerator as sine of x times 1. And so now I can set up a series of 2 trigonometric functions multiplied by each other, so that I can have 1 over the cosine of x, which is, well, we know that is secant of x, and then sine of x over cosine of x, which we know to be tangent of x. So this derivative is secant of x times the tangent of x. And so now we have the derivative as secant as well. So because sine of x and cosine of x are differentiable functions of x, the related functions, tangent, cotangent, secant, cosecant, which are made up of sines and cosines, are differentiable at every value of x for which they are defined. Their derivatives are here. We know the derivative of tangent is secant squared. We just found it. But the derivative of cotangent is negative cosecant squared. The derivative of secant of x is secant of x tangent of x, while the derivative of cosecant of x is negative cosecant of x cotangent of x. And I'm going to place over here on the left the derivative of the sine of x, we know is cosine of x, and the derivative of the cosine of x is negative sine of x. So I want you to make a note here that all of the derivative of the co-functions, cosine, cotangent, cosecant, they're all negative, and their derivatives are essentially the co-functions of the derivatives of sine, tangent, and secant. So I'm going to skip example 4. That's best left for class. We're going to move into example 5. Find y double prime if y is equal to the secant of x. So we know y is secant of x. We now know then that y prime is the derivative of secant of x, and that's secant of x times tangent of x. Next, for y double prime, what we'd want to do is use the product rule, since we have a secant of x times a tangent of x as y single prime. So the product rule says to take the first function, which in this case is secant of x, and multiply it by the derivative of the second. I'm going to use a notation of putting that second function in parentheses and using the prime notation up above it. And then plus the second function, tangent of x, times the derivative of the first function. I'm going to put secant of x in parentheses, prime. Now we're going to replace those prime notations with their actual derivatives. So we have secant of x times derivative of tangent of x is secant squared of x, plus tangent of x times derivative of secant of x, again, is secant of x tangent of x. And finally, if we have secant of x times secant squared of x, that's secant cubed of x. Plus, we have tangent of x times a tangent of x, so that's secant of x times tangent squared of x. And we have a final for y double prime in this case, and that is the derivative of all 6 of the basic trigonometric functions.